We're being asked to find all the asymptotes, intercepts, and holes and use that information to graph the following rational function. The way that we want to start is by simplifying it as much as possible. We can simplify it by factoring the top and the bottom completely. We notice that the top is already factored. However, we can factor the bottom. We're looking for two factors of 6 that subtract to 1, so that's going to be -3 and +2. We can see that nothing cancels out, and therefore the only domain restrictions are going to end up being vertical asymptotes at the end because nothing canceled out. So the domain is going to be everything from -infinity to -2. We leave out the x is equal to -2. We also leave out 3, and everything else is included in the domain. Now, the next thing that we're going to look at is the vertical asymptotes, and since neither of these factors canceled out, both of these domain restrictions are going to translate to vertical asymptotes. So we'll see that we have two vertical asymptotes. One of them is going to be at x is equal to 3, and the other one will be the vertical line, x is equal to -2. Both of these are essentially going to become like fences or lines that you cannot cross in the graph. Now, to look at the horizontal asymptotes, we need to consider the degree of the top and the bottom. So in the top, we have a degree 1 polynomial. In the bottom, we have a degree 2 polynomial. And when the degree of the bottom is a bigger degree, that means we're going to have the horizontal asymptote y is equal to 0. In this situation, we get the horizontal asymptote y is equal to 0. When we have horizontal asymptotes, you don't get oblique asymptotes. So there are no oblique asymptotes in this case. Now, for the x-intercepts, as you will recall, we find the x-intercepts by plugging in y is equal to 0 and then solving for x. So let's do that. This was our original function. We could also write it in the factored form, but when we plug in y is equal to 0, we really have the option to use either one of these. However, I personally like to use the factored versions of my rational functions when finding intercepts and asymptotes. We're going to come over here and plug in 0 for y and then solve for x. So now, once we've plugged in 0 for y, we now have a rational equation with one variable, and we should recall that in order to solve that, we're going to multiply both sides by the LCD. But in this particular case, the LCD is going to be this x minus 3 times x plus 2 all over 1. Now, when we multiply that on the far left, we're still going to have our 0. And when we multiply the LCD on the far right, it just cancels out the denominators, so we're left with just the numerator, 6 times x minus 1. So solving for x now, let's divide both sides by 6 to get that 6 out of there. And we'll end up with x minus 1 is equal to 0, so x is equal to 1 after we add 1 to both sides. So let's clarify our final answer that the x-intercept is just that x is equal to 1, causing y to be equal to 0, so we only have the one x-intercept. Now, in order to find the y-intercept, let's recall that we plug in x is equal to 0 and then solve for y. So here we have the two versions of our original equation. In this case, I find it a little bit easier to use the original version. So let's plug in x is equal to 0 for all of these terms here. So we'll end up with 6 times 0 minus 1 is -1 in the top, and in the bottom I have 0 minus 6, which is -6. So we have -6 over -6, which is +1. So let's formalize our answer here to say that the y-intercept turned out to be when x is equal to 0, we got y is equal to 1. Because we didn't get any cancellation, there were no factors that canceled in the top and the bottom, that means that we're not going to have any holes in this graph. So let's remember what we found from above. We had the vertical asymptotes that x was equal to 3 and x is equal to -2. X is equal to 3 again is a vertical line at the x value 3. We also have a vertical line at x is equal to -2. So let's plot that line and also label it. For the horizontal asymptotes, we found the horizontal line y is equal to 0 to be the asymptote. Y is equal to 0 is the equation for the x-axis. The x-intercept turned out to be the ordered pair 1, 0, and we calculated the y-intercept to be 0, 1, and we also found that there were not any holes. Now, it is a good time to mention that you are allowed to cross a horizontal asymptote, cannot cross a vertical asymptote, but we can cross horizontals. The y-intercept is 0, positive 1, so that's going to be right here. And again, we want to label all of our points. And this actually doesn't give me a whole lot of information to go on. About the only thing that I can really see is that I pass through these two intercepts and then approach the asymptotes. That means that my graph is likely going to come in like this, somehow in the center, but that's really just intuition telling me how that fits together. But I do need to figure out what's going on over here and what's going on over here. Sometimes we can use our x-intercepts to help us figure out where the graph is in those regions, but this time I think let's just jump over to the calculator and plug in our function. So we'll say alpha f1 to get our numerator denominator, and in the numerator we had 6 times x minus 1, and in the denominator we had x squared minus x minus 6. So let's pop over and see what our graph looks like. Notice that we put in the original function, not the factored version, because it's better to go back to the beginning equation to put it in your calculator, just in case we made a mistake in our algebra. And so far, it looks kind of like we've got that center version correct, but the calculator is helping me to understand that over here in this first quadrant, my graph is occurring above that horizontal asymptote, and then over here in the third quadrant, my graph is going to be below the horizontal asymptote. So let's come over here and graph that. So in this region, my graph is going to be approaching the asymptotes in that first quadrant, and in this region we're going to be approaching the asymptotes in the third quadrant, and we really kind of needed the calculator to help us figure out how to fit those pieces together. So we can also come back to our calculator and verify a couple of ordered pairs by using the second calculate value function to see what our y-intercept would be. We do have the correct y-intercept, and if we plug in x is equal to 1, we see that we also got our x-intercept correct.